Okay, so this unit is going to be on trigonometry, and in this first section we're going to be taking a look at reviewing the material that you learned in geometry on right triangle trigonometry, but we will be adding a few things to your knowledge base from that course. All right, so the first thing we need to do is look at our trig ratios, and you may remember your acronym from geometry of SOHCAHTOA, SOHCAHTOA, and what that means is that S, which is sine, and that is equal to the opposite leg divided by the hypotenuse. The C stands for cosine, and cosine is going to be the adjacent divided by the hypotenuse. And then T is your tangent, and tangent is equal to opposite over adjacent. Now, when you have a right triangle, the hypotenuse is the side across from your right angle, and the other two sides of a right triangle are called your legs. And so when we refer to opposite and adjacent, we are referring to the legs of the right triangle. Now, we are going to be bringing in three more trig functions. The first one is going to be secant. SEC is the abbreviation for secant. CSC is the abbreviation for cosecant. And then COT is the abbreviation for cotangent. All right, so the ratios for secant is equal to the hypotenuse divided by the adjacent leg. And what you may notice is that this ratio is the reciprocal of this ratio, which means secant and cosine are reciprocals of each other. Well, what that means down here is that cosine is equal to 1 over secant of theta. All right, so the next ratio is for cosecant, and that ratio is the hypotenuse divided by the opposite leg. And you may notice that this is the reciprocal of sine. And so we can fill this in down here, that sine of theta is equal to 1 over cosecant of theta. And then the last ratio is for cotangent. It is equal to the adjacent over the opposite leg. And that is the reciprocal of tangent. So tangent and cotangent are reciprocals of each other. All right, so in this, what we're going to do is find the 6 trig ratios for this triangle. Now, in order to find the 6 trig ratios, we are going to have to know all 3 sides of your right triangle. Now, if you know 2 sides of your right triangle, you can find the third side by using Pythagorean theorem. A squared plus c squared, a squared plus b squared equals c squared, where c is your hypotenuse. So in this situation, the a and the b are 5 and 9, so you have 5 squared plus 9 squared. Does not matter which one is a and which one is b. And so you're going to have 25 plus 81, which is 106. And so c is equal to the square root of 106, and that is the length of your hypotenuse. So the sine of theta where theta is this angle right here, 5 is your opposite leg, 9 is the adjacent leg, and 106, square root of 106 is your hypotenuse. So using those references, sine is equal to opposite over hypotenuse, so that is 5 over square root of 106. Cosine is adjacent over hypotenuse, so that's 9 over square root of 106. And tangent is opposite over adjacent, so that is 5 over 9. Now, secant, cosecant, and cotangent, if you will just remember what the reciprocals are, that will help. Secant is the reciprocal of cosine. So this will be square root of 106 over 9. Cosecant is the reciprocal of sine. So this is square root of 106 over 5. And cotangent's reciprocal of tangent, so that will be 9 over 5. Now, one way to make sense of this, cotangent and tangent, these two make sense that these are reciprocals of each other. The other two don't really, the other four don't really make a whole lot of sense why they're reciprocals of each other. So let's try to find a way of being able to memorize that. If you will see, this starts with an S, this starts with a C. So S and C, like Samuel Clemens, these are reciprocals of each other. Secant and cosine, also SC, Samuel Clemens. Those are reciprocals of each other. So if you'll remember the S and the C functions, these are reciprocals of each other, secant and cosine, and then sine and cosecant. Those are your reciprocals. All right, so one of the things we want to look at here is what if we take a look at the sine ratio over the cosine ratio. Well, the sine ratio was 5 over square root of 106. Cosine ratio was 9 over square root of 106. And that means the numerator, which is this, divided by the denominator, which is a fraction, so you would multiply by the reciprocal. And the square root of 106 cancels out, which will leave us with 5 over 9. Now, if you will notice, this is the same thing as this right here. And what that tells us then is that the sine of theta divided by the cosine of theta is going to always give us tangent of theta. So tangent of theta is equal to sine divided by cosine. And then if we look at cotangent, well, cotangent is 9 over 5, and we could get that by just flipping this over. So cotangent is equal to cosine of theta divided by sine of theta. These are two properties for trig functions that are going to be used frequently in your future. All right, so go ahead and take a second, and I want you to pause the video, write this problem down, complete it, and then unpause the video and check your answers. So go ahead and pause your video at this time. All right, so welcome back. You can check your answers here. And what we had to do is find the length of this third side of our right triangle by using Pythagorean theorem. So you had a squared plus b squared equals c squared. And that gave us the missing side had a length of square root 51. And then using our trig ratios, we have these values here. All right, so we're going to be using right triangle trigonometry and those ratios that we've looked at for two main purposes. The first purpose is going to be finding the length of the sides of the right triangles. And the second purpose is going to be finding the measures of the angles of the acute angles of the right triangles. Now, this is the foundation for trigonometry. These trig ratios and the trigonometry that we are doing in this section. And what that means is that there is much, much more to come in regards to trigonometry, and everything is going to be built on from this concept right here. All right, so problem here says find the length of the sides of this right triangle. The information that we need in order to do this is the length of one side and the measure of one of your acute angles. And remember that the angles of a triangle add up to 180, and because we are dealing with right triangles, the Pythagorean theorem does always apply on these whenever we need to use that. All right, so if we want to find the length of the sides, let's start with side x. Well, if you use the information that is given to you, which is this side and this angle, and then we're looking at x, we don't need to pay any attention to y and z at this moment. For this angle, x is directly across from it, so x is your opposite side and 6 is your adjacent side. Well, opposite and adjacent tells us that we need to use the tangent function. All right, so that means the tangent of 40 degrees is equal to opposite, which is x, over adjacent, which is 6. And now we need to solve for x, and we will do so by just multiplying the 6 over to the other side of our equation, giving us x equals 6 times the tangent of 40. And the tangent of 40 is 5.03. All right, so now, if we do the same kind of thing to find y is our hypotenuse, and we are still using the 6, which is our adjacent. So adjacent and hypotenuse tells us we need to use the cosine function. So the cosine of 40 will equal the adjacent side, which is 6, over the hypotenuse, which is y. All right, so what we would do to solve for y here, because it's in the denominator, we would multiply y over to the other side, giving us y times the cosine of 40 is equal to 6. And then we divide by cosine of 40, so that gives us 6 divided by cosine of 40. Now, what we just did right there, we normally will just do in one step. Whenever the variable you're trying to solve for is in the denominator, you're just going to move it over to this side and then move your trig function down to the denominator. So that would give you 6 divided by the trig function. Okay. Now, in this situation, 6 divided by cosine of 40 gives us a y value of 7.83. And we also need to find z, which we can use the property that angles of a triangle add up to 180. Now, we are only dealing with right triangles in this section, which means if this angle is 90, these two angles that are the acute angles have to add up to 90, because 90 and this 90 would give us 180. Well, that just tells us that z would have to be 50 degrees. All right, so I want you to take a few minutes, copy this problem down, find the length of the sides and the missing angle z. Pause the video and then when you're done, unpause the video and you can see your answer and check your answers. All right, welcome back. So you can check your answers here for the values of x, y, and z. And one of the things I want to point out here is that we can kind of get an idea of whether our answers are in the ballpark or not by remembering our inequality property of triangles from geometry, where if this is our largest angle, the side across from it, which is the hypotenuse, has to be the longest side. So that's one of the things you can check, is that your hypotenuse is definitely the longest side, which it is here. And we also want to check the smallest angle. The side directly across from it has to be the smallest side, which it is in this situation. And then the middle-sized angle across from it would be the middle length. Now, something else to refer to is if you look at the proportions of these angles, this angle is a lot bigger than this angle is. And the side across from the largest angle is significantly larger proportionally to the side across from the smaller angle. Now, what I want you to think about also is, what if you had a right triangle where you had like 46 degrees and this was 45 degrees? Well, in this situation, this side or this angle is larger than this side, this angle, which means this side has to be longer than this side. Now, because these angles are pretty close in size, that means that this side would be just a little bit larger than this side. And that applies no matter if it's right triangles or any other kind of triangles. This triangle actually is not a right triangle, but that property applies. If these two angles or any two angles are pretty close in measurement, then the sides across from them will be close in measurement as well. So the second thing that we're going to be using our trig functions for is finding the measures of the acute angles of a right triangle. Now, in order to find the acute angles, what we need to know is the length of two sides of our right triangle. So in the problem that we are given here, we know this side and we know this side. So we have the length of two sides. So let's take a look how we find angle x. All right, so for angle x, the sides that we are given in reference to x, 10 is the adjacent side, 25 is the hypotenuse. So adjacent and hypotenuse is cosine. So therefore, the cosine of x is equal to the adjacent over the hypotenuse. Now, we need to solve for x in this situation, which means we need to get cosine, just the cosine, over to the other side. In order to move your trig function only and separate it from the variable, you're going to be using your inverse functions. So what that means is that x will equal the cosine inverse of 10 over 25. And in this situation, x is equal to 66.4 degrees. Now, for y, the 10 is no longer the adjacent side. For y, 10 is the opposite side. So we have opposite and hypotenuse. So that will give us the sine function. So the sine of y is equal to 10 over 25. do our inverse. So y is equal to the sine inverse of 10 over 25, which is 23.6 degrees. Now, these two angles right here should add up to 90 degrees because that 90 degrees added to this 90 degrees would give us 180 degrees. Now, we can also find z, and z we would find by simply using Pythagorean theorem. So you would have z squared plus 10 squared equals 25 squared. That's 100. This is 625. So z will end up being the square root of 525. Yes, that can be simplified or done, a lot of different things done to it, converted to decimal. I'm just going to leave it as square root of 25 for this purpose. So I want you to pause the video once again, copy this problem down, find the measures of the angles and the length of side z. So go ahead and pause the video, and then when you're done, unpause and you can compare your answer. All right, so here's your answer revealed. We found z by using Pythagorean theorem here. For x and for y, we used tangent, but the ratio was just a little bit different. Tangent of x was 9 over 8. Tangent of y is 8 over 9. So now we're going to be looking at some terminology that's going to be used in your application problems. And the main terms that you're going to be looking at are going to be angle of elevation and angle of depression, where the angle of elevation is the angle formed from a horizontal line going up. So here is your angle of elevation. Here's your horizontal line. So if you look up, that angle is your angle of elevation. Angle of depression, you can think about depressing, goes down, elevate, goes up. Angle of depression is the angle formed from the horizontal going down. So over here you have your horizontal, and if you go down, that creates your angle of depression. So let's take a look at this example here. Person is standing 50 feet from the base of a building and looks up to the top edge of the building. The person is 5 feet tall and the angle of elevation is 55 degrees. What is the height of the building? All right, so the first thing I want to do is you want to get a picture or draw a little picture of what is happening here. All right, so just draw my little stick figure man right here. And then we've got a building going up like this. Very crooked building, but you got the idea. All right, so here is your horizontal from the eyes going up, and then we have the angle right here. So the angle from the horizontal going up, that is our angle of elevation, which is 55 degrees in this particular problem. All right. So then we also have the fact that this man is 5 feet tall, and the person is standing 50 feet away from the building. All right. So what we need to do is find the overall height of the building. Now, the measurement from here to here, we can find using our trig ratio. I'm going to call this h. So in this problem, we would use our tangent function. So that's going to give us tangent of 55 is equal to h over 50, opposite over adjacent, which means h is equal to 50 times the tangent of 55. So that gives us h is equal to 71.4 feet. Now, remember what the question asked, and the question asked, what is the height of the building? 71.4 feet is not the height of the building, that's the height from here to here. So we have this part right here, which was the height of the person approximately, assuming the eyes are at 5 feet. So we got an additional 5 feet, so the overall height of the building is going to actually be 76.4 feet tall. All right, go ahead and take a second. I want you to write this problem down, draw a picture to show what's happening, and then work this problem out. And then pause the video before you work the problem out. When you're done, unpause it, and you can see the answer revealed. All right, so we can see from the picture here, the angle of depression. You got a lineman at the top of a pole, and the angle of depression, which means from horizontal going down. That angle is 62 degrees. Well, this forms a right angle because the pole is vertical to the ground, which means we have a 90-degree angle here. So if that's 90 and this is 62, this angle has to be 28 degrees. And we've got a 40-foot pole. Here's our truck. And so using the 28-degree angle, this is the opposite side, this is your adjacent, so we use tangent function and find out that x is equal to 75.2 feet. Now, something else to remember is that if you have a horizontal line and you look down, this creates an angle of depression right there. Now let's draw a horizontal down here. This would be your angle of elevation. Now, if you will remember some properties from geometry, if this line and this line are parallel to each other, and you have this line which intersects both of them, this line is called a transversal. That creates these two angles which are called alternate interior angles. And the property from geometry is that if these two lines are parallel, which they are, then alternate interior angles are congruent. Well, what that means is that your angle of depression and your angle of elevation are always going to be congruent to each other. And what that means in the context of this particular problem is that if this angle up here, which is your angle of depression, is 62 degrees, that means the angle of elevation, which would be this angle, would also be 62 degrees. So this angle right here would be 62 degrees. So this method here is not the only way we could have set up this problem. We could have also set up the problem as tangent of 62 degrees equals 40 over x, which would give us x is equal to 40 divided by tangent of 62 degrees. That also will give you 75.2 feet. So it's just an alternate way of being able to find the same answer.